So today's lesson, formalizing relations and functions. It's not a lot of stuff, but there's a couple of things that are extremely important and very confusing. Put your phone away. If you're not paying attention, particularly at the end, you will be completely lost. If you do pay attention, it's not too difficult, but you need to pay attention to what we're doing. The part at the end in particular really, really is important, and it can be difficult to follow. Okay, vocabulary and definitions. First thing, a relation. A relation is pairing of numbers with a domain and a range. An equation will give you a relation. Equations are types of relations. Okay? Domain and range, we'll talk about those in a minute. But a relation is anything where you have an input value and an output value. Okay? You have X's and Y's. You have A's and B's. Anything where you have a relationship between two numbers. These numbers are paired. A set of coordinate numbers. That's a relation. Okay? Equations describe relations. The domain is the set of independent variable values. The domain is usually the x coordinate. It is also your input. What we put into an equation is our domain. You get to pick the domain. You get to pick the input values, the x coordinates. Those are your, generally speaking, your domain. Okay. Your range. This is the set of dependent variables. It's usually your y values. It is also would be considered to be the output. Your domain are the numbers you stick into the equation. Your range is the numbers you get when you put them in and you evaluate. Okay. Domain and range. Domain and range are very, very big concepts in what we're dealing with in math. Okay, I talk about domain and range in a lot of my classes. The farther on you get, the more domain and range become important. Domain are all your possible inputs. Range are all your possible outputs. What can I stick into the equation? What can I get out of my equation? Okay, domain and range are important values. Vertical line test. So some relations are functions. And we'll talk about what makes a function as we go through. Okay? A vertical line test is a way of telling is something a function or not. It is one way to tell if something is a function or not. What you do is you pass a vertical line across a graph, either a set of numbers like we're going to have, or we have a graph of an equation, a line, a curve, whatever. If you pass a vertical line across that and it touches more than once at any time, it's not a function. For something to be a function, the vertical line has to touch once and only once at any particular time. If that vertical line crosses more than once, it's not a function. At any time, not everywhere, just someplace. Okay, and we'll do some vertical line tests coming up here in a little bit. Okay, function notation. This is probably the most difficult part we're going to be dealing with today. Okay. Function notation is something that was going to get very, very important. Function notation is you're taking y and replacing it with f of x, and that's how you say it. You say f of x. So f of x is this, f of x is that. You can use other numbers or other letters, and we will be doing that. Function notation gets used more and more and more the higher up you go in math. Function notation is extremely useful, and it works better in many ways than than using y values. So an example of function notation. Normally we would have the equation y equals 3x plus 1. This is normally what we see in an equation. Y equals 3x plus 1. This is a regular equation. We have y equals something. What function notation does is it replaces the y. Okay? And what we can do is rewrite it in a different notation. It's just a different way of saying the same thing. Function notation is just a different way of saying the same thing. Instead of saying y equals 3x plus 1, we say f of x equals 3x plus 1. G of x equals 3x plus 1. Or whatever we want, we can state that. Okay? The nice thing about function notation, and you will see this example later, makes it really, really, really easy to evaluate things. You used function notation when you were doing your skill test. It was E of F when you took your skill test on Tuesday. You had the function E of F equals, and you had an equation in terms of F. That was function notation. Okay, I like function notation. I prefer function notation over y equals because it's easier to do certain things with it. And we will do the example today that is really, really good for function notation. Okay, but you're going to see function notation more and more. And this means the exact same thing as this. It's just a different way of writing it. There's reasons for writing it differently. Okay? Questions so far? And once again, this is f of x. This is g of x. That's how you say it. Okay? And anything we put in there, let's say we put in 3, we would say f of 3 or g of 5 or whatever we do, and we will do that later. Okay, so let's start doing our tests. So identify the domain and range of each relation, representing the relation with a mapping. We'll talk about that. Is the relation a function or not? So what I have up there is I have 2 different sets, and this is one set, this is another set of xy coordinates. This is a relation. Every x has a corresponding y with it. I have an x, I have a y. I have an x, I have a y. I have an x, I have a y. That is a relationship. For every x, I have a y. That is a relation. I've defined my relation by those xy combinations. Okay? What I want to do is rewrite it as a mapping, and that mapping is just a different way of stating this. It's a different way of giving that information. Here's how mappings go. First part of your map, and the mapping is basically what you have is you have 2 circles. There's the first one we're going to do it first, or 2 ovals. The first one is my domain. My first oval, my first circle, my first group is the domain. The domain are all my x values. So I have -2, I have 0, I have 4, and I have 5. That's my domain. All the x values are my domain. I make an oval that has all of my x values in it. Okay, that's just grouping my domain together. Okay. And if I have my domain, then I have to have my range. And if my domain is all my x values, my range would be all my y values. Okay? So my y values are 0.5, 2.5, 6.5, and ooh, I have 2.5 twice, right? I do not write 2.5 twice. I only put it down there once. Every y value, if the y value is repeated, I don't write it every time it's there. I just write it once in my mapping. So I would have in this group here 0.5, 2.5, and 6.5. Now this is just grouping my domain and my range. That's my domain is my x's, my range are all my y's. Domain and range. Here's where the mapping comes into place. What you do is you take every x and connect it with its y that has to go with it. So I have -2 connects with 0.5, -2 to 0.5. I draw the connection from the x to the y. My next x is 0, it connects with 2.5. My next x is 4, it connects with 6.5. And then my last x is 5. And what does 5 connect with? 2.5. So I just have it going to the same 2.5. That's okay. Now I have one other question I need to answer. It's a yes or no question. Is this relation a function? Is this relation a function? Yes or no? And I haven't talked about what makes it a function yet. Here is the complicated answer. I know, you got to start out the complicated one first. For it to be a function, each x has to have just one y to go with it. Each x has its own y, has one y. That y may be shared. All the x's may have the same y, that's okay. But one x cannot have two y's. One x, one y. I can have 3 x's or 4 x's have one y. I cannot have one x have two y's. Okay. So if I look at this one here, -2, how many y's does -2 have? 1. How many y's does 0 have? 1. How many y's does 4 have? 1. How many y's does 5 have? 1. It is shared, that y is shared from 2 x's, but it only has one y, so this would be a yes. This is a function. So let's do a mapping on the second group here. Oh, I can't move that up. Good. So we'll do the exact same setup. We'll do our domain. Our domain has our x values, right? We have 6, 4, 6, and 5, but remember we don't write them more than once. So I have 6, 4, and 5. I don't need to put them in order. I just put them in there. It's nice that they can line up in straight vertical line. It makes it a little easier to do your mapping later. You know, don't write them all in a group. You want it neat. Okay, there's my domain. Do the same thing for your range. Remember the range are my what? My y values, right? So in my range circle, I put in 5, 3, 4, and 8. 5, 3, 4, and 8. Does that make sense so far? It's not difficult, but you have to be careful and pay attention to what you're doing. It's not a difficult task. Okay, here's the part that you have to be also very, very careful on. Map them. Take each x, connect it with any y that goes with it. So I have from here, I have 6 goes to 5. From this pairing, I have 4 goes to 3. From this pairing, I have 6 goes to 4. Uh-oh. I can do that. Don't get me wrong. That's not what the uh-oh is about. And then my last pairing, I have 5 to 8. So that's the mapping. Yeah, it's a little bit of work, but it's not that hard. 2 circles, list the x's, list the y's, draw the lines from your x's to the y's that go with them. Second part is the difficult part. Is it or is it not a function? Now remember the rule is each x has to have only one y to go with it. Is that a function? No, it's not a function because my first x, 6, 6 has how many y's? 2 y's.
2.
I have 2 y's for 6. I have more than one line coming away from a number here. This one is not a function. That's a no because of this pair there. I have one x that has 2 y's. 6 maps to 2 different numbers. It's okay to have 2 numbers go to the same y. It is not okay to have one x have two y's. I can have 2 x's have 1 y. I can have one number over here, and if all my x's go to that one number, that's okay. Having one x go to more than one over here is no bueno. Function, not a function. Is it still a relation? Yeah, it's still a relation. It's perfectly good. It's valid. It's great. I love it. But it's not a function. This is a function. This one's not a function. Okay? That's one way to tell whether or not something's a function. The next one is the vertical line test. I like the vertical line test. It's an easy test to do. If you have a graph, you can just take and pass a ruler over it and see if it intercepts it more than once. We have this situation here where we have dots. We don't have any lines. I don't need to connect the dots up. Here's what you do. Is you draw a vertical line through every single dot. So every dot has a vertical line on it. Do any of those vertical lines have more than one dot? Yeah, right here. Remember, the vertical line test is only one through each vertical line. I have a vertical line that has 2. This one failed the vertical line test, which means this one is not a function. No, that is not a function. It failed the vertical line test. I have 2 dots on one vertical line. More than one dot on any vertical line, not a function. Okay? So I do the same thing here. Do it on this one. See if you have a function or not. You can go over that, and I've got a smart word thing for that too.
For this,
Yeah.
right.
Did this pass or fail the vertical line test? This one passed. So is this a function?
Yes.
Yes, this is a function. Okay. Now, let's say, for example, you had a graph like this. It's hard to draw a vertical line through every single point on a graph like this, is it not? Here's what you do if you have a graph like this. You just imagine that, hey, I've got a ruler, that I pass a ruler in front of that graph or over that line. Does that ruler touch this at more than one place at any time? No, it doesn't. So this one would pass the vertical line test. If I have something like this, would that pass the vertical line test? No, in fact, it would fail it at several places. Okay, and that's literally what I do is I'll take, or in your case, if you got a piece of paper, you've got a paper for you, just take and pass your pencil across it. If your pencil hits more than once, it fails. Okay. Okay, now we get to function notation and using function notation and why function notation is good. Okay. Evaluating a function. The function w of x equals 250x represents the number of words W of X that you can read in X minutes. This is where function notation works well, and you did function notation when you were evaluating doing the skill test the other day. Function notation works really well if I want to evaluate something again and again and again. Rather than plugging in X and finding Y, plugging in X, finding Y. Now, which X went with which Y? It's very difficult sometimes to keep track of that if you're doing it over and over again. With this one, it's not. And here's what function notation works. It wants to know how many words can I read in 8 minutes. This means I want to know what W is when X equals 8. I want to know what W is when X equals 8. Here is how you do it with function notation. I have the equation W of X, or I should say the function, W of X equals 250X. I want to know what it is when X is 8. I take X, replace it with 8. This is now, instead of W of X, this is now W of 8. W of 8 is equal to, I took this X here and replaced it with what? 8. So I'm going to take this X here and replace it with what? 8. That's how you evaluate a function. Whatever you put here, you put there. 250 times 8. The W of 8 is 250 times 8. And how do I do that? I take 250 times 8. That tells me that W of 8 is 2,000. 250 times 8 is 2,000. And that's how you say that. W of 8 is 2,000. What is W? W is 2,000. You do not continue and try to solve for W some more. The biggest mistake students make when they're doing this is they go, ooh, I want to know what W is. You know what W is. You do not go past this. You do not do anything to this. You do not get W by itself. You have what you want by itself. I want this equals something. I don't want to do anything more. That's the biggest mistake students make when they first do this, is they want to keep going. Ooh, what's W equal? We don't solve for W. W is not a thing we solve for. W is our function notation. It's just how we say it. We do not solve. We do not go any farther. I've done everything I can do at this point.
Think of it as Y equals 2,000.
Yeah. This is Y. W is W of X is another way of saying Y. This is a way of saying Y at 8. And when X equals 8, what's Y? That's what you do. Okay. Now, a little more complicated, but not much. Finding the range of a function. So I'm given a function f of x equals negative 1.5x plus 3, or sorry, plus 4. Plus 4. It's hard to see the negative on your notes. Be careful you see that negative on your notes. Okay. And you're given the domain. Your domain is your x values. These are all my x's. It says, what's the range? It wants to know all the y's that go with all of those x's. You have a bunch of x's, now you want to know the y's. Here's what you do. You take these one at a time and put them into here. This is where function notation works really well. I want to do it for 1. So so what I do is I say, okay, what's f of 1? Well, I took the x here and replaced it with 1. So I take the x here and I replace it with 1. Negative 1.5 times 1 plus 4. And I bust out my calculator and I figure out what this is on my calculator. Take negative 1.5 times 1, add that to 4, and you get 2.5. So when x is 1, y is 2.5. There's one of my y values. Now I have to get the rest of them. So I do the same thing again. And this is what I like about function notation. I figured out what it is for 1, and now I want to do it for 2, so now I take f of 2. How do I know it's not the same y value? Because I know from function notation, this is what it is when it's 1, this is what it is when it's 2. I took x here, replaced it with 2. I take the x here, replace it with 2. Negative 1.5 times 2 plus 4. And you put that in your calculator. Negative 1.5 times 2 plus 4, you get 1. So when x is 2, y is 1. When x is 1, y is 2.5. When x is 2, y is 1. I did 1, I did 2. I have to do 3. F of 3. Negative 1.5 times 3 plus 4. I took x, replaced it with 3. I take x, replace it with 3. Whatever I put in here for x, I put in there for x. That's what's nice about function notation. I can stick anything I want in there. Whatever I put here, I put there. And it doesn't have to be a number. I can stick any freaking thing I want in there. It doesn't matter. Okay, it can get quite complicated as we go through. Multiply it out. Add them together. 1 negative 1.5 times 3 plus 4 gives me negative 0.5. And then I have to do it how many more times? One more time, because I got to do it. I did it for 3, now I got to do it for 4. F of 4, negative 1.5 times 4 is plus 4. Once again, I replaced x with 4, so I replaced x with 4. Negative 1.5 times 4 plus 4 gives me negative 2. I know, a lot of work, and you're going, oh, thank God it's over. It ain't over. Because what I did was I found the y's to go with every x. These are my x's. These are my y's. But what it asks for is, what's the range? So I need to say my range is, and I have to give a list of these in brackets, just like it gave me the list in the brackets up here. And I put down what those y values are that I got. Now, if I were to do this and be very strict and proper, I would have it numerical order from smallest to largest. For this class, I really don't care. And just put down the 4 numbers that I got. You want to be nice and neat and pretty and super duper duper proper, please put them in numerical order from smallest to largest. But once again, as long as you give me the list of all the proper y values, I don't care. Okay? Questions? Okay. Uno momento.